Welcome to our second section in our third module named Value of Technology. Sounds like a very intuitive title. We'll talk about a few frameworks of how, certain industries and certain types of companies think about the value of technology. If we take increasing returns industries, right? In the previous section, we talked about how dominant designs emerge, how the standard battles essentially generate certain types of winners. There is a couple of factors of how value of technology is being thought of, right? So the first one is technology standalone value, right? So the standalone value of a smartphone, right? We kind of use it, right? I mean, it's very smooth. It's very aesthetic. It performs a certain amount of functions. Then there is network externality value. And we talked about that briefly when we said, hey, if there is enough users, the more users there are, the more value that kind of creates per user. And we used the example of Facebook. In this case, right, if we take the iPhone, the network externality value is really their ecosystem, right? The App Store and these things, iTunes, right? And so not only does the smartphone smooth, right? It's easy to use, but it also connects you with a lot of other options, right? And apps are a massive innovation, right? The ability to use certain functions, right, to program these specialized apps to perform certain functions, and them essentially being their own innovation is actually quite extraordinary, right, and has led to Apple being valued at over $1 trillion at this point in time. And so when we think a little bit about that, right, so technology value, if we take the customer side, there is different types of utility levers, right? And they're not all the same. We can generalize a few utility levers, but they might be a little different for each type of technology. Let's take the Toyota Prius, right? So what's the utility of that car? The standalone value, right? The technology standalone value, one of the distinctions is that it's a hybrid, right? So meaning you can you have your gas powered engine, but you also have an electric motor that gets charged when you brake, for example, and then you can release that energy, and that means you don't have to use the gas powered engine all the time. Now, so we have environmental friendliness, right? That was added throughout the 2000s. Wasn't always a major priority for US consumers and US car makers, but turns out that was really a significant differentiator for many people, right? Not only saving gas, but saving gas and helping the environment. And so marketing it that way was really helpful for Toyota. The customer productivity part of it, right? And so there's different dimensions. There's a purchase, delivery, use, supplements, maintenance, and disposal. And obviously with electric vehicles, there are some advantages, right? So typically, in this case, it's a hybrid, right? But typically, if you have an electric vehicle, for example, you have a lot fewer moving parts, right? Because you don't have a transmission, you don't have all the parts that are related to the transmission. So that can help in terms of maintenance. However, at the same time, your battery doesn't last that long. You have a problem with finding, places to recharge your car and so on and so on. So there is these different types of utility levers that kind of emerge for customers. And that's a big thing if you think about your technology, right? So whether you develop the technology for whether you commercialize the technology of your choice in option one, or you're looking at QuantumScape and what are the utility levers for their customers, you have to kind of think about this very systematically. Now, again, we talked about externality value. the size of the technology's installed base, right? So how many users do I have, and what kind of complementary goods do I have? And so we've seen many technologies or many innovations that had strong technology standalone value fail because they didn't have enough complementary goods. Typical example is a game console, right? And I don't know, maybe some of you remember the Neo Geo. That was a very, very advanced game console. Ended up not being so successful in the market because they couldn't get enough developers to, it was very expensive, of course, but in addition to that, they couldn't get a lot of developers to develop games fast enough to get the adoption curve going. And so is important, right? So what are complementary goods? In Apple's case, it's their iTunes or their apps, right? That's their complementary goods. Think about what's a complementary good for a computer, right? That could be software, right? So programs, things that you can use the computer for. Yeah, and so you have to think about that, not only develop the technologies installed, the technology standalone value, but also think about the installed base and complementary goods. And so it's not enough to be technologically superior. You have to be a lot more technologically superior in order to kick somebody, to push away a dominant technology or a dominant design. It's actually not so easy, right? Even if you have the better tech has to be significantly better. Or if you want to compete, you need to have similarly complementary goods and as a result, installed base. And this is kind of a conceptualization of this, right? So you have somebody with new technologies, right? And typically new technologies have more technological utility, but if they don't have enough technological utility to bypass the existing designs, and by a lot more means that it's so superior that even if you don't have enough complementary goods yet, or you can build your customer base slowly, right? So if we think about Tesla, right? Tesla is a good example, right? The technological utility of the Tesla was pretty strong. It didn't have yet a lot of complementary goods. It didn't yet have a huge customer support, but over time, that superior technology, that superior driving, the driving feeling of how to kind of use an electric car, that innovation was so significant that it actually overcame that kind of limitation that, you know, their competitors with their sophisticated supply chains and like GM and Ford, who had kind of a lot of experience in building cars, they couldn't compete finally with the Tesla, and now they have to essentially switch to the EV technology as a result. So it's what technology value is not necessarily objective, right? So it depends more on perceptions and expectations of your customer in many cases. Customers might have a great drive a Tesla and they're just enthusiastic about it. That's not necessarily objectively meaning that that's the better car, but that is exactly what you're looking for, right? If you put new tech into the market, you have to create this kind of massive difference in perception and expectation and motivation on the customer end. Now, we're looking at this, and these different things can be disproportional, right? So this is kind of our actual number, right? Then this is how it's perceived, and this is how it's anticipated. It happens with different technologies, right? And the other question here is, we have different customer groups who have all these different expectations and anticipations of the technology. So we have to be very strategic about understanding the customer, and that's going to be one of our next modules, kind of defining business models, customer segmentation, market segmentation, Also really important things for your final project. Again, we use some examples: Alexa, Apple's App Store, Roku, right? Roku is also a good example. Good technology, clever technology, right? Not necessarily a quantum leap in terms of technological prowess, but really clever, right? So they combine, they give you the option to kind of operate multiple streaming services and kind of software that is related with smart TVs, right? So they recognize that smart TV is going to be important. They also needed smart TVs for their technology to be successful. Similarly to smart TVs, encouraging users to use Roku, because that enhances that smart TV dramatically. And similarly, we have Alexa in the App Store. I don't use Alexa, but there's plenty of my friends who use Alexa, and they find that very useful, especially when you're cooking, right? And you don't have to kind of scroll through things on your phone. You can ask Alexa, or the equivalent. I think Google has another equivalent to kind of help you figure these things out. And this is kind of a progression, right? We talked about payment processing. This was one of the older, cashier machines. Then we came to kind of the digital standalone, and this is our networked digital payment processing machine. And there's different utility levers at different times. You can imagine that these two are really superior to kind of writing by hand and figuring out by hand, especially when you have a lot of customers, right? When you have just a few customers, this is not super problematic. But if you have big grocery stores like Walmart, imagine they would operate with these kind of machines. It's really difficult. And when you look at, cashiers and these, they also have a lot of complementary goods, right? So you can use credit cards, you can probably use Apple Pay, et cetera, et cetera. The compatibility and the possibility to use different devices with that are pretty significant. Again, so here is the question, and this is a little bit theoretical, so you don't have to worry too much about it. But think about, we talked about network externalities. And so if we have a dominant design, right, and we kind of have our value, the value of your technology, right, becomes greater as your market share increases, right, as more people are using it. You can imagine, right, that as you improve your technological utility, you're increasing another level of value to that, right? And so depending on how your tech is here, right, how important or how powerful your tech is, or what it does, it can give you an extra bump in terms of your technology value for the customer. Again, this is just an example where we have different companies, right? And they kind of share market value, and we kind of trying to assess market share, and we're trying to assess value. And so what we just simply see is that if my technological value is high, right, as my technological value, as the market share increases, right, the value for the technology increases as well. But depending on my standalone value of the technology, right? So I have a better iPhone, or I have a better car, right? I can move that curve upwards, right? Becomes more beneficial to me, but only for a specific value. And again, if a good example of this is the video game industry, right? We have multiple competitors. We don't have just one or two consoles. We actually have quite a fair variety. And it just simply means that I don't need to have an excruciating amount of users for users to get utility out of it, right? So if I have a Nintendo and other people and somebody else has a Nintendo, there might be levels of value that I can achieve with a lower amount of customers, right? There is a certain satiation point, right? On Facebook, I don't need to connect with 3 billion people, right? There's currently 3 billion active users. My utility for Facebook probably has a certain threshold, right? After that, my utility probably stays the same or even goes down, right? Because I get a lot of spams and a lot of scam messages, right? And so that's a hard thing to think about, right? So where is the value for the customer or the technology value maximum? And that also means that you don't have to target a tremendous amount of users, right? It might be that your app or your application works perfectly and very profitably with 100,000 users or 1 million users. And so that's something you have to figure out as your technology kind of moves forward. So we talked about winner take all markets, and that had to do with, remember the natural monopolies. We are used to competition, right? And we want competition, but there are cases, let's take the example of railroads, or take the example of phone lines or nuclear power plants. It wouldn't make a lot of sense to have cutthroat competition for nuclear power plants, because if we would take a risk that that people would kind of ignore their safety to make an extra buck or to get a competitive advantage. So over competition can kind of have some disadvantages here. This is kind of a theoretical question, but so what should we do, right? So what should the governments do? What a government do when there is a natural monopoly, right? There's benefits to it, right? There are benefits to natural monopolies, but there's also disadvantages such as price gouging, restricted product variety, et cetera, et cetera. Again, there is kind of a similar discussion when generating energy, right? So we have these natural monopolies for utility companies. And so a lot of people want to have more decentralized power generation. And so naturally there's a little bit of friction there. Anyway, economists have figured this out, right? So there are certain curves where the natural monopoly, until when a natural monopoly generates, consumer benefits, and after that threshold is essentially not so beneficial to consumers. And these are kind of the policy discussions we've seen in Washington, also related to big tech, right? At what point do consumers are consumers hurting because of these monopolies? All right, that finishes our second section, and soon we'll talk about our last section of our third module, namely a discussion about modularity and platform ecosystems.